All right. So we're back in lecture mode. There's a homework, and it was due at 5 o'clock today. And if you didn't submit it, you're late. Did anybody have any trouble with the homework? No?
The only question which I posted on the discussion board.
Okay, you had a question, and I think you asked, first question, what is a constraint?
Yeah.
And do you have a good answer for that now?
Yes.
Okay, and what is a constraint?
I think it's any restriction for my work, like if there's kind of problems to get the information, or there's a restriction to get this information.
I'll give you an example of a constraint. We see here a device called a chair. Right? The chair is able to roll around in the two-dimensional coordinate plane, which is representative of the floor. Right? It can roll in any direction you like. It is very different than a car. A car cannot roll in any direction you like. A car is subject to constraints whereby you use the rear wheels and they are straight, and you have the front wheels and you do the steering. And if you want to orient the car in a different direction, you've got to maneuver the car until you get the car in a different orientation. You can't just take the car and move it straight to where you want it. So the car is subjected to a constraint. And that constraint for the car, as an autonomous land vehicle, a computer-controlled car, is subjected to what's called non-holonomic constraints. So when you have an engineering problem, right, you say, I would like to be able to move the car from here to there, subject to the constraint that you can't just move directly, because cars have funny things. Chairs can do that, but cars are not chairs, and cars don't have casters. So cars are different. And so they are subjected to constraints. So when I say, what is the constraint? I'm talking about an engineering constraint, a mathematical constraint. Other constraints may also exist. You might say, I would like to be able to power a microcontroller, subject to the constraint that I not use more than, let's say, 100 milliwatts. Because if I use more than 100 milliwatts, I will drain my power reserve. So you're trying to build some sort of wireless sensor that's going to give you information about how something behaves, monitoring a complex machine like a helicopter. So maybe you say, well, I will harvest the vibration of the helicopter. Helicopters vibrate a lot. Take that vibration, use your, I'll call it low power energy harvesting circuit, and charge up your capacitor. I can now transmit information about stress and strain within the helicopter fuselage. But I am subject to the constraint that I not use all of the power available to me in my little capacitor, maybe 100 milliwatts, and that's it. So I have to do 100 milliwatts over 17 seconds, and then I'm done. I have to shut down and charge up again. And maybe I can measure every, 10 seconds, and that's good, because I can take 10 seconds to charge, and that's sufficient. And then as long as the helicopter is running, as long as it's vibrating, which is whenever it's running, I'll be able to charge up my little sensor and transmit back to Computer Central, which will say, oh, the laminates are coming separated, and the helicopter is in danger, and therefore you need repair. And this is one of those basic, sorts of problems that people have with helicopters today, because helicopters have airframes which stay in service for way too long. And helicopters are not made of metal anymore. They're made out of laminates, which are basically woven graphite with different weave angles and Kevlar. So, as it happens, because they're in service for so long, we'd like to be able to monitor their health over a long period of time without wiring them all up with lots of different sensors and without giving the sensors power. So if we can harvest the power and use low power sensors, that's a very good thing. So as I see it, that's a basic constraint, right? Basic constraint on an engineering problem, which has to be stated precisely, because otherwise you don't know if you've solved the problem, the correct problem. So a good problem statement is a necessary but insufficient condition for coming up with a good engineering solution. If you stated the wrong problem, if you solved the wrong problem, then you've got a problem because you don't have the right problem. So having the right problem is very important. Somebody said to me, I'm very worried about the energy that's being consumed by a transistor when the circuit is off. I said, you're working on a bad assumption. This is the wrong problem. You're consuming 50 nanoamperes when the transistor is off. Don't worry about that. That's at the noise level, because the other things that are going to be consuming power at 100 milliwatts, for example, those are the things we need to worry about. The transistor, when it's off, it really is off. And so leaking a little current at 50 nanoamperes, that's nothing. So I say, that's the wrong problem. So don't worry about the wrong problem. Don't worry about the little noisy thing. Worry about the big problem, the important problems. These are the ones that you really have to identify when you come up with a thesis statement. Did anybody have a chance to read some of the prior work that was done by some of the students who've gone through this class before? No? That's a big mistake.
I saw the...
You saw a couple. Yeah. You should look at what people have done. See what the other students have done. See how they stated their problems. I think that I'm a little surprised, because I would have thought you would at least have paid some attention to what others have done in this course. You're not the first people to have taken this course. So when you look at courseware over in here, and you go down to thesis work, you'll see these are thesis students who actually have a thesis. Not all my thesis students have decided to post their theses, but you can look at prior thesis work. Moreover, there are a number of people who have proposals, but they didn't necessarily do a thesis. And in fact, some of the people, as I see Andrew Gust over here, are patent attorneys. Right? He had an interesting problem that wasn't just a problem, it was an invention. Right? And so what he was trying to solve was the problem of being able to take pipes and weld them without any fire. Because one of the constraints is the pipes are right next to drywall. And if you use a torch to melt solder, it's possible you could cause a fire. So he wanted to do some welding without any heat. And so he had an interesting problem, and the constraint was use no heat and still proceed to make a good, what you might call, weld. And so he called it the magnetic pulse welder, and he had a patent out of it, so he had a proper invention. Sure enough, one of my plumbers came to fix leaks in my house, and they had something also able to weld without any heat. But it didn't use a magnetic pulse. It was a pure compression system and used very special couplers in order to be able to accomplish the feat. So look at this. How clean. I've got a problem statement, a motivation, an approach. Right? This looks like a proper outline. I have a historical review, and then there's the literature cited. Right? So if we think about it, this is not an annotated bibliography. That's what Jackie had talked about last week. Right? Instead, it's a proper literature review. And every time you review the literature, you are supposed to cite it. You know, for every single paper that you read, write a paragraph or at least a sentence or two. So the goal is minimize cost of joining tubes, and then such that, and here's this constraint, we're going to reduce energy usage and material requirements and make a good bond. Right? So how do we do that? And the motivation, right? When you think about motivation, you think about societal impact. Why do we care about this? Maybe it's a product. Maybe we can make money, but somewhere there should be some value that's added. Right? If you want a product, then you think there's a market for it. Somebody should care about this, and you should be able to tell us why. Why is this important? Who cares? And if the answer is, well, I as a plumbing contractor will be able to show up to your house and make welds that are good, that do not leak, that I won't have to revisit, and I can do them 10 times faster than anybody else, I don't care if they cost 3 or 4 times as much. I don't care if I need special couplers for these things, or even a tool that costs $1,000. I don't care, because I can get in and out. And normally I charge people, perhaps $120 an hour. Around here, they charge you just to show up, right? You cannot get a plumber to walk through the door of your house in this state without an upfront payment. Usually it's something like $85 or $100, believe it or not. So they won't even come to the house until you agree to pay the minimum, because of transportation costs and because of the overhead in our traffic. It may be different in some other countries, probably more reasonable, right? Do people have to pay up front to get a plumber to show up in India? No, they don't. Maybe we should get them to come here and do plumbing. It's our plumbers here in this state make more money than me. So I'm very jealous of our plumbers, but they work hard, and they also know how to do plumbing. When I do plumbing, everything leaks. It's true. I'm not a good plumber. MPW is magnetic pulse welder. That's this. The approach. We're going to get to this, right? The approach. Yes, sir.
So I have a question. It seemed like in the assignment you wanted more than just the problem statement. You were giving us like the entire outline. It sounded like you wanted. And I'm like, this is a 21-page paper basically that covers the literature history and the other paragraphs that you've been discussing over just the problem statement. So I was wondering how much development of, right now if we've done our problem statement, there's going to be more development that's going to be going on later.
Yes.
Also more editing to our original problem statement. So I'm wondering how our
problem
grade on this assignment is going to be changing throughout.
Yeah, so that's a very good question. Let's go back to the Blackboard. My content, is that it?
That'll get.
And now, where is... What has happened?
Go back to
Click
my institution.
click course content on the left.
My
maybe.
institution.
My institution.
And here you will see your courses.
And now I should see ECE 420.
Yeah.
And now I should see my content.
Course content.
And now I should see homework number 2.
Right.
So, here it is. Problem statement.
Yeah.
Given, subject, find. Right? So I don't see in here in the problem statement.
In the approach, I think.
No, yeah,
The
so
approach and the
it's
motivation.
very easy to set up our problem statement, but then the approach and the motivation,
Motivation,
other
yeah.
paragraphs following, they require more in-depth research
Right.
and formulation of how we're going to actually solve the problem and things like that. So it's hard to formulate all that now without having done all this research and preparation.
Well, what it says here is revise your problem statement so that it is a formal engineering problem statement as described in class. And then I write in engineering, an introduction may contain subsections of problem statement, approach, and motivation. But you're not going to write the introduction.
Okay.
You're going to write the problem statement.
Okay.
All I wanted was the goal
Just
of
have a
homework
good
2
problem
is to have a proper formal problem statement.
Okay.
We wrote approach.
Yeah, the other things which we're going to get to for our next homework assignment include some of the items like your approach to solving the problem. So if you told me that the problem is to try and make good welds, like Andrew Gust did here, maybe the approach is to create a magnetic pulse welder. Well, obviously, there's more than one way to weld a pipe, right? Maybe you can weld a pipe with a compression welder that uses pure mechanical action instead of magnetics. Maybe you could weld a pipe using something other than that, perhaps clamps with screws on them. I don't know. How does one weld a pipe? See, this is why everything leaks in my house. Don't weld like that. So I'm thinking that your approach to the problem may involve a specific invention that gives you a sustainable competitive advantage so that when you go to manufacture, you'll have a patent that effectively allows you to have a monopoly over the product. And then when you start to manufacture, if somebody sees this product and says, that's great, you can sue them. And then, if you want to, you can even license to a big company and you can let them sue them. And then when they sue them, they're going to say, we're going to keep you from manufacturing this unless you license from us. So this is how you create a sustainable competitive advantage, because the big company that licenses your idea from you is going to patent it not just in the United States, they'll patent it in the Paris Convention Treaty countries, which could be 17 member nations, in Canada, in Japan, in China maybe anywhere within the civilized world, right? You're going to be able to say, they have to pay us money. That way you can say, I've nailed down the invention. In my last international patent, we had PCT, the 17 member nations, the United States, of course, Japan, and Canada. We did not do China because it seemed too hard and ineffective, but that was expensive. And after we were done with all the licensing fees during the life of the patent, we spent over $100,000. Very expensive, because you had to keep hiring attorneys in different countries and translating the patent to different languages. So this is what happens if you try to use, your innovation as a means toward commercialization, right? You want to commercialize your innovations, you've got to do something. Either you build a business or you license it. Otherwise, I don't know how you would I don't know how you would monetize your innovation. Some people would say that makes you a businessman. But here in the New Age, we call it entrepreneurship. But it's the same thing. Makes you a businessman. So there was another question you had, Tariq. Constraint and what is the body of knowledge? Right. What's the body of knowledge? And I think you were not so sure about that. So I'll give you an example back to how do I write a thesis, right? So we go in here and we look at the historical review, right? And in the historical review, we are trying to describe things that are related to what we're working on, right? So this is what I would call the subject area. So let's say the subject area is cold welding, right? Because we're trying to do plumbing without fire. Maybe a lot has been written about this already. Maybe there are 1,000 papers out there, but there are certain seminal papers that we care about. And so what we can do is we can say in the subject area there is a large body of knowledge about cold welding. And maybe there's two kinds of cold welding, those that use pure mechanical forces and those that use magnetic forces. And we just want to focus on the magnetic forces. And then you could just focus on a fewer number of papers. What was your topic?
The electronic health records.
Electronic what now?
Electronic health records to detect diseases. I'm going to
Electronic records.
the electronic health records.
Health records.
Yeah, I'm going to use that to predict some diseases.
To predict a disease? All right, so let's assume that you found out that the incidence of a disease, let's say breast cancer, was highly elevated in some place, let's say Long Island. And it is. That is true. And it's a deadly disease. Kills people. Maybe this is one of those areas where you could say, I see there are a great deal of other kinds of cancers which happen. Let's say colon cancer. stomach cancer, maybe esophageal cancer, also with high incidence. Maybe from those datum, you can make a conclusion. Your hypothesis is there's something in the water that people are drinking. And to test the hypothesis, which is your approach to validate, your assertion, you need to somehow collect data by mining the data records and say, there are these people who drink bottled water by survey, and they don't get these cancers, and there are those that drink tap water, and they do get these cancers. And then you could say there's something in the water. Maybe it's trichlorofluoroethanes. Maybe it's some kind of volatile organic compound. Who knows what it is? Maybe it's something the industry dumped into the groundwater and somehow made it into people's houses through the tap. So as it happens, you as a data mining person can come to interesting diagnostic conclusions. And your approach to validate your hypothesis effectively allows you to use your data mining even further to see the emergent properties that you've discovered and try and test your hypothesis with other sorts of things that you can devise, like an instrument, like a survey, that says these are the people who are drinking the tap water, and they are also correlated with the people who are getting the cancer. Now, you might find out it's not the tap water. That allows you to discover that your hypothesis is not right. Maybe it's because the people eat at McDonald's, and McDonald's gives you cancer. I don't know. Something that they do that's bad. Maybe they all smoke. So if you have a survey that says, do you drink tap water? Do you smoke? And you find out, well, tap water isn't giving them cancer, it's smoking. You can say, no wonder they're getting sick. They're smoking. So it's not clear why they're getting these cancers. We know that they are. We can observe that they are, but there's a big difference between correlation and causation. And so you need to somehow find out what's causing using your data mining. So now you have a proper approach, and when you look at your historical review, data mining healthcare records is part of a body of knowledge known as healthcare informatics. Healthcare informatics is a humongous field. This big, giant, humongous field. So now you're in a field which has lots of papers. And many of those papers are in PubMed. No? You can't find healthcare informatics? I don't believe it.
Actually, how to use this information to predict diseases.
Healthcare informatics comes right up. You can get master's degrees in this.
No.
There's people who study this, they get degrees in it. Right? You can go, if you wanted to, you can go to PubMed. And you get full disclosure from the National Institutes of Health. And then if you wanted to, you could search on cancer. Let's say, pick your cancer. I'll do breast cancer and water and see if anything comes up. Only 1,800 papers. You telling me you can't find any papers?
It's not like that. Okay, I will see that.
This is there are compelling. Maybe you could do an advanced search, and you'll find that there are ways in which you can refine this search to make it a little bit better. Huh?
Break.
Huh?
You need a break.
You need a break?
Yes.
6 o'clock? Okay. Let's take a break.